Good afternoon, everybody. It's my pleasure being here in Korea again and share our view from Europe about non-terrestrial networks. We had on Monday already a big session with a lot of details, and I hope I can contribute and fill the gap what is happening in Europe in research and also in development. So if we talk about 6G, then we have all different views, and currently we try to converge what are the views, what can we do better, what we have to improve, new technologies in the field. And we have different dimensions how to do that. I mean, we can go for more antennas, we heard that, massifications of antenna arrays, we can shorten delays, and we can go to different frequencies. And in early time of spectrum discussion, we talked already up to the sub-terahertz spectrum. Currently, my feeling is that this is not really the day one technology we have to expect in 6G. Nevertheless, there are frequencies below the classical millimeter wave range, FR3, which are put in focus, and that fits also well with established frequencies, for instance in Ku band, which was used for satellite. And if you look what's else to be expected, that's, I mean, 3D dimensions for the network in the future. I mean, what we know, what we are doing, let me go back. What we know, what we are doing, you can't see that. The lower ground, the terrestrial network is well established. We know how to do that, to densify, use new frequencies. But there is another layer we really expect, and there's high altitude platforms and satellites in different altitudes to contribute for coverage, resilience, and connectivity. And if we look at the map, here is one map where data is collected from mobile phones. I mean, so we see where a lot of mobile phones are connected to 5G networks. And you see that's mainly the well-developed countries and where most of the population is. I mean, here's one flaw. I mean, China is well connected with 5G, but these phones usually cannot deliver the data to the collector's network, so we don't have that. And there are other regions where we have a lot of population, but the networks are not as developed as in let's say, in Asia or in the Americas or in Europe. And that means there is a lot of space and area on this globe where people are living, but they are not connected to the same level as we experience like here in Seoul or in other big cities. So that's motivating to fill these gaps, and this in a really efficient manner. And if I may add a story, I was recently for the 3GPP plenary in Melbourne, and after that I was traveling for 2 weeks with my family, and we had a camper van, and I can tell you basically every camper in Australia is using Starlink. So you go to a campsite and then you see 20, 30, 40 Starlink antennas all going up, turning, tilting, and then they have 100 or 200 megabits per second. So there is a system working and people use it. So that shows me, okay, if you don't have cellular coverage or if you are in nowhere, it works. And we should have this also with more proliferation in the market. And so this was also a big discussion when we developed 5G, where the vertical sector of the satellite community made it into the arena, into the 3GPP community. They established their position quite well. We had a couple of study items. Now we are working on NTN using the 5GNR waveform enhancement for that, also going for IoT. And it's not going IoT over, let's say, geostationary satellites. I mean, you can do that, and we are also partner in an early adopter program for NB-IoT over satellite with geostationary satellites with Deutsche Telekom. And I can tell you it works, but if you don't see the satellite because you don't have view to the south in northern Europe, then you never have a connectivity to the satellite. So LEO satellites will make a big difference in providing this connectivity. And then there is another case, positioning. I mean, we have GPS and other systems with satellites around the globe. But what we know and what we experience is that these signals come from far away and they are easy to spoof or to jam, which has, might have sincere consequences for the users relying on these systems. And if we, let me talk a few moments on the different satellites we have basically here in orbit. So we have these geosynchronous satellites. They are very far away. They are stationary over a certain region. That works, but long distance, long delay. And because of the distance, the received power is quite limited. The footprint is large. And we have to share the resources in the footprint with many, many users. So per user, the data rate is very, very low in the end. So if you get closer to MEO or LEO satellites, then latency goes down and also capacity can be scaled by the density of these satellites. And that's basically the goal, what should be envisioned. And you see the companies operating different satellites or want to operate these satellites. So there are quite a few companies really operating there. But looking backwards, when satellite community had their own waveforms and their own systems, like 12 years ago, I just found out these slides. We worked with a small company and they wanted to know if they can use LTE over satellite. And basically we just converted over a bent-pipe satellite, an unused Russian satellite we used those days, and used this and really could achieve 16 QAM with very limited changes in the baseband software and processing over the satellite. And that gave rise really to push into that area. Those days we got a lot of criticism. Meanwhile, everybody understands, okay, using the same technology like terrestrial networks allows scalability, reliability, and in the end, everything in one device. Terrestrial connectivity and satellite connectivity. And since that, a lot happened, and we see here, I hope you can see that on the left-hand side, is the current constellation from Starlink satellites. I took this picture last night. So they launched 7,000 satellites, 600 have been burned already, and 4,600 are active. And you see they have special trajectories so they can cover where the continents are. They don't have good coverage over the pole. And that's different with OneWeb. So they really go over the pole. They have polar orbits. So they have a lot of satellites on the pole where there is nobody or not many people. And then they have, meanwhile, all the rings closed and have at least coverage. And then on the right-hand side, you see the satellites of GPS, much further away. That's why the Earth is much smaller. And that's another layer which is there. But if you consider all these low-orbit satellites much closer to the Earth and with a much higher density, then navigation positioning can be assured with these as well. But we have to see how to do that so it really works for many, many devices and in every spot of this planet. And then in order to push into this market, we have a lot of proprietary solutions where companies build partnerships. I mean, we have recently when we had a meeting in China from 3GPP, we we entered all the shops, and we saw many of the phones were basically with a satellite logo, so they provide already connectivity to one of the Chinese satellite. I think it's China Telecom. They operate a satellite, so they have like a messaging type of communication. And then iPhone, they had discussions. They have a partner, so they can use LTE. And there are other options really for NB-IoT or for NTN IoT, really to use currently, let's say, proprietary solutions just to test the market. And just to let you know, we have recently or just now started a study item in 3GPP or a work item where Iridium, one very established player, having global coverage in sub 2 gigahertz band, they use a TDD structure. I mean, usually satellites work on FDD, but they use TDD since, I don't know, since ages, and it works. And they need adaptation of narrowband IoT also to support such a, let's say, duplexing mode. And then all of a sudden, if you do that, then immediately you have a deployed infrastructure, you have devices, and you can scale from day one. So that's very promising. And I mean, having said this, it's a clear indication that we should have a non-terrestrial network as an integral part of 6G from day one, and for different use cases. I mean, for broadband, in particular, where broadband is not provided everywhere in a country, in a region. Then, of course, IoT, because what I heard from different operators, NB-IoT is perceived with a different flavor. Some of them say, oh, it didn't scale, it's a big failure. Others say, oh yeah, it's a success story, but we need a lot of devices to be connected. So really having one infrastructure, and it works interoperable everywhere on the planet, across borders of countries, is very beneficial. And you see some of the, let's say, players in the satellite space, they have plans when to deploy geostationary or non-geostationary services in near future to be active there. And not going too much into detail, what we have to do for the radio network adaptation, certain things have to be adapted because of the link budget we have to expect from space. We have, let's say, different beams. We have to work differently on a base station, basically operated from outer space, because we can't have, let's say, 1,000 beams active at the same time. I mean, there is just power limitation. So you will have a subset of beams active at the same time, and others are muted. So we need changes in how to do beam management, what a UE should expect to log on to the signal, and so on and so forth. Furthermore, we have a changing distance. I mean, if you're on ground, your distance to the base station is the same. Even if you move, it changes slowly. But if you have a satellite flying over you, then basically your delay between satellite and Earth is changing over time, and you have to accommodate for that. You need, let's say, we have a timing advance usually to send back to the satellite, and that's changing while the satellite is flying, so a lot of changes have to be made. And then what's really important is the uplink capacity, because usually the device has limited power, and if you have your phone in your pocket, it should talk to the base station on a control channel. You have to work with that. And then one big part in 5G is RedCap. It's called Reduced Capabilities Terminals. And some people say probably the market will consist of mainly 60 to 80% of these devices, which don't have everything, but they're good enough to use the 5G network. And these devices also have to be adapted for non-terrestrial network. And then, I mean, for NTN IoT, there are a lot of discussions how to do that. one simple example is if you have a narrowband connections, for instance, if you have NB-IoT, then NB-IoT is not connected to the IMS server. So if you want to really do voice over NB-IoT, we need changes. Because bandwidth-wise, that's possible, but how we are implementing it in the network, it's not possible yet. So there's a lot of things we have to do and to address. I'm not going into details what the challenges are. You can contact me if we want to further discuss on this topic later. But one very important topic, and that's indicated also by ITU, that the spectrum will be a big topic for the next World Radio Conference, is that the upper mid-range spectrum is also used by many satellite applications and operators. So this is a very, highly contested spectrum. And I mean, we can do it the old way. We give it to them, or we give it to them, or we think about coexistence. I mean, non-terrestrial and terrestrial co-use, and this is adjacent band and co-channel use, which is a big topic. I think it's very new to the telecom industry in particular, because so far we gave spectrum nationwide to 1, 2, 3 operators, usually different spectrum, so they could coexist. Here we have base stations flying around the globe, and if they are active, then they will be close to certain spectrum on the ground. So this is a very important topic, and one way to address it is recently started technology. It's called subband full duplex. We saw slides on that, and we believe the mechanisms developed there will also be beneficial for coexistence of satellite and terrestrial communication. And in that area, Europe is doing a lot of research. We have a big European Horizon project, and to just give you an idea, these are the many projects active. One of these is 6G NTN. I mean, there is a website, you find it on the slides, so you can look it up in detail. It's more informative that a lot is happening in parallel to what 3GPP and ITU are doing. So you see the lower bar, that's the research done in Europe, which is well aligned with the global initiatives for standardization in the long run. But let me give you a bit of an idea where we are standing in Europe, and we have a big platform. It's IRIS². It's a new EU secure satellite constellation, and maybe if I may ask you to play the video that should introduce what this is about.
Access to reliable, secure and ubiquitous connectivity services increasingly relies on space capabilities. With the development of a state-of-the-art connectivity system, Europe can offer enhanced communication capacities to not only governmental and institutional, but also business users. By relying on disruptive technologies, including quantum cryptography, the multi-orbital IRIS² is designed to offer global coverage for both fixed and mobile platforms. Based on a seamless integration with existing infrastructures, it strives to ensure secure and resilient broadcast services in challenging communication scenarios for civil and defense uses. Supported by the blending of public and private funds, the system aims to enhance European strategic autonomy, digital sovereignty, and competitiveness. Strengthening the synergies between space, digital and security services, it supports the economic and societal growth of the EU, while supporting social cohesion through the reduction of the digital divide. IRIS² constitutes today a new space pillar for a digital, resilient and greener Europe.
Thank you very much. And I mean, to give you some ideas on the technical details, I mean, there was 2 weeks ago was a presentation in RAN 1. You see the contribution number down there, so you can download the slides. Basically, it's a joint project in Europe, and you see it's allocated quite substantial funding on the ground, basically from the governments, 2.54 billion euros, and then it's extended then from public-private partnership, so really establishing basically a network in Europe. And I showed that with different orbits, so the idea is really using existing constellations and bring up then more satellites where needed to complement the multi-orbital constellation, and what it's targeting for global coverage, and then have, let's say, the security by design in it. And I think, I think it will turn out a global consensus that if you want to use satellites to cover a certain region, except if it's a geostationary satellite, you have to build a global network. And this global network is then only active over your certain region. So really sharing such networks across different nations makes a lot of sense in terms of investment, maintenance, operation, sharing the burden, and have good technology. On top of it, you can, if you have the right agreements, really have country-specific requirements to be, let's say, reflected, like encryption, what you want, or whatever security applications you have. And then with these networks, you can cover either, governmental institutions, defense operations, or civil operations. And this can be a very good complement to what we heard from Nakamura-san today with high-altitude platforms, which are just a few, I don't know, was it 20 or 30 high-altitude platform rings you showed in your picture? That gives a motivation. You can handle this as a country, but the satellite constellation might benefit substantially from collaboration. If you're interested, here you see the ground segment, all the things which have to be implemented, developed. Then you have the space segment, the users, and the network in that area. And what is important, IRIS² will really go on to standardized technology, standardized 5GNR is really the radio interface. They will build SatCom terminals which can operate on 5GNR. They have a SIM card, so all standardized technology. So in principle, it can interoperate with any terrestrial network. And that allows then really have mesh topology, so you don't have to go to ground to interconnect two terminals. That's on the left, or you go through the core network between countries if you have a ground station in between. And in the interest of time, I'm not going into the details of technology, just to say that IRIS² is a strategic asset for Europe, for the security and of its member states. And we really try to go with forward-looking technology built on 5G, NTN standards, in space, ground, and all the segments. Yeah, stay tuned. We are building on that, and the tender is ongoing, and the companies are starting to be ready for deployment and integration. Thank you very much.